In this example, we're going to look at discharging a capacitor, which, if you recall, is going to use a different set of equations. Again, I've got some of those equations at the top, but not all of them. And of course, 45 is going to be like 39 from your homework, but it's not going to give you exactly the same assortment of information, right? In this case, they're giving you the time constant. They're not giving you things like the initial charge and the resistance and all that sort of thing. Okay, but fine, you would still approach the problem in roughly the same way, using the same set of related equations. And also, as usual, things like maximum values are, the term that's, right out front of the equation. Okay? So let's watch the action. So I'm starting off with the information that they tell you the time constant is 1.5 seconds. This might frustrate you because you're thinking, I don't know R or C. How can I do anything? But you can. You can do quite a bit with that because R and C in the exponent part of the equation are always together. So if RC then is 1.5, that means you don't need to worry about actually what either of them is, because you have what they multiply together to give you. All right, now since it's talking about charge, I'm able to use the first equation up above, and it gave it to me in kind of an odd way. It says, 75% of the initial charge. So I don't have any particular numbers, but I do know it's 75% of whatever it started at. So in my algebra then, what you'll see is I will can't be able to cancel out the initial charge, and just that factor of 0.75 is going to matter. All right, and so 0.43 seconds later, the capacitor will be down at 75% of its original charge. Notice that's actually independent of how much charge that actually was. So at any, if you want to look at any particular 0.43 second time interval, that means it will have lost 75% of whatever it had at the beginning of that 1.5 second time interval. Or, sorry, at that 0.43 second interval. All right, let's keep going. Next, it's asking us to determine the capacitance. So again, I'm using that fact that time constant is RC. Okay, and that's some straightforward algebra. Now, I'm going to approach a hypothetical question here because you have to look at this sort of thing in number 39. What if they had said, what's the initial current? Now, it turns out we don't have enough information for that. But I'll take a stab at it. Notice, as usual, the initial values are the thing at the front of the equation. So if they had said, what's the initial current, and that actually told you the initial charge, then we could calculate it using what I got right here. I did start in kind of a funny place, and the reason I did this is because sometimes they will tell you a capacitor is charged to, and then not give you a charge, but give you a volts. So if they do that, then you would do it just like this. Instead of trying to figure out the charge on it, which you might not even be able to do, you would just use the volts that they gave you. So if they said, charge a capacitor to 9 volts, that means ever so briefly it's like a 9-volt battery, and then the current would be just 9 over the resistance. Okay, and if they say at some particular time, then you can plug in values from there. Okay, I hope that was helpful. If you feel like you need more basic information, then feel free to go back and look at some of the other videos I have on RC circuits. And of course, as always, stop by if you have questions, and I will be more than happy to help you. Thank you very much.